Hello, everyone, and welcome. Today, we're going to tackle a really important concept, invertible matrices. Now, the name might sound a bit heavy, I know, but trust me, by the end of this session, you'll realize it's just a fancy way of saying the undo button for matrices. So, let's get started.
All right, let's start with something you already know. Something super simple. Look at this equation. 5x equals 10. How do you solve it? Easy, right? You'll just say, sir, divide by 5, and you get x equals 2. But what are you really doing? You are actually multiplying by 1 by 5, which is the multiplicative inverse of 5. Now, look at the right side. We have a matrix equation, ax equals b. So what do we do here? How do we get that x all by itself? That's our big question for today.
So the first thought that comes to mind is, can't we just divide B by matrix A? Simple, nah? Well, here's the big twist. In the world of matrices, there is no such thing as division. It just doesn't exist. So this is a puzzle, and the solution is actually very, very clever. Let's see what it is.
Okay, so if division is off the table, how do we solve anything? Well, we have a secret weapon, a special tool for matrices. It's called the inverse. And like I said, it is literally the ultimate undo button. Okay, let's get the proper textbook definition out of the way. I know it looks a little bit scary with all these letters like A, B, I, M, but don't worry. Forget all this for just a second. Let's break it down with a super simple example that you actually use every single day.
You're all on Instagram, right? So imagine matrix A is the action of you tapping the follow button on someone's profile. You have performed an action. Now, what is the one and only button that can perfectly reverse this, that can take you back to the state where you were not following them? Exactly, the unfollow button. That unfollow button, that is your inverse matrix, or A inverse. It takes you right back to where you began.
Now, what does it mean to be back where you began? Well, when you follow someone and then immediately unfollow, what's the end result? It's as if nothing ever happened, you know? You're back to the original neutral state. In the world of matrices, this neutral state has a special name, the identity matrix, or I. It's just like the number 1 in regular maths. So, follow, which is A, times unfollow, which is A inverse, brings you back to neutral, which is I. Simple, no?
All right, now pay close attention here. This is super, super important. For a matrix to officially be the inverse of another, for it to be the real unfollow button, it has to pass a very strict test. Think of it like a two-way security check.
And this is it. This is the golden rule. AB must equal I, and BA must also equal I. It's not enough for it to work in just one direction. It absolutely has to work both ways. It has to be mutual.
And I am telling you this because it is the most common trap in exams. Seriously, so many students will calculate AB, they'll get the identity matrix, get excited, and then move on to the next question. That's a huge mistake. You have only done half the work. You must check BA as well. If you don't, you will lose marks for sure. So don't be that student.
All right, enough talk. Let's get our hands dirty with an actual example. We're going to put this golden rule to the test, and you will see it's really just some simple multiplication. Nothing to be scared of at all. Okay, so here are our two matrices, matrix A and matrix B. The question is, are they inverses of each other? Is B the unfollow button for A? Well, there's only one way to find out. We have to perform our two-way security check. So first, let's calculate A times B.
Okay, let's do this together nice and slow. Remember, it's always row of the first matrix times column of the second. For our first element, top left, we take the first row of A, that's 2 and 3, and the first column of B, that's 2 and minus 1. So it's 2 times 2 plus 3 times minus 1. That is 4 minus 3, which is 1. Great start. Now for the top right. First row of A, second column of B. 2 times minus 3 plus 3 times 2. That's minus 6 plus 6, which is 0. Looking good. Bottom left now. Second row of A, first column of B. 1 times 2 plus 2 times minus 1. That is 2 minus 2, which is 0. And finally, bottom right. Second row of A, second column of B. 1 times minus 3 plus 2 times 2. That's minus 3 plus 4, which is 1. And look at that. We get 1, 0, 0, 1. Hey, that's our identity matrix. Perfect. So check number 1 is a success. AB is equal to I. But wait, are we finished? No way. We're smarter than that, right? We have to do the second check. We have to calculate BA. Now for the other way around.
BA. This time, we take the rows of B and the columns of A. Let's go. First row of B, 2 and minus 3, times the first column of A, 2 and 1. So we get 2 times 2 plus minus 3 times 1. That's 4 minus 3, which is 1 again. Looking good. Now first row of B, second column of A. 2 times 3 plus minus 3 times 2. That's 6 minus 6, which is 0. Okay. Second row of B, first column of A. Minus 1 times 2 plus 2 times 1. That's minus 2 plus 2, which is 0. And the last one, minus 1 times 3 plus 2 times 2. That's minus 3 plus 4, which gives us 1.
And there you have it. Once again, we get 1001, the identity matrix. So BA is also equal to I. The security check is complete. Both sides have passed.
So because AB equals BA equals I, it is official. It is confirmed. B is the inverse of A. And you know what? That also means A is the inverse of B. It's that mutual relationship we were talking about. See? Easy peasy. It's just a little bit of careful multiplication.
Okay, before we wrap up, I want to share some pro tips. Think of these as the little secrets that separate the students who score full marks from everyone else. These are the hacks and the exam traps you absolutely need to know.
Rule number 1. Only square matrices can even have an inverse. So if you see a rectangular matrix, don't even waste your time trying to find one. It's impossible. Rule number 2. The inverse is always unique. A matrix has only one inverse, just like you have only one fingerprint. There is only one perfect unfollow button.
And finally, rule number 3. This one's a little bit tricky, so listen carefully. It's called the socks and shoes rule. It's for finding the inverse of a product, like AB inverse. Now, you might think the answer is just A inverse times B inverse. Wrong. You have to reverse the order. It becomes B inverse times A inverse. Think about it logically. In the morning, you put on your socks first, then your shoes. To undo this at night, what do? You take off your shoes first, then your socks. You have to reverse the order. It's exactly the same for matrices.
All right, that was a lot, but you did an amazing job. Let's do a super fast final recap of everything we just learned to lock it in your brain.
So what do you absolutely need to remember? 1. An inverse is just an undo button. Simple. 2. The golden rule. AB equals BA equals I. You must check both sides. 3. Only square matrices can have an inverse. And 4. The sock-shoes rule. Remember to reverse the order. The inverse of AB is B inverse times A inverse.
Seriously, you all did a fantastic job today, but I want to leave you with a little puzzle to think about. We know that a matrix must be square to have an inverse. But does every single square matrix have one? Is it possible for a square matrix to just not have an undo button? And is there a faster way to know without doing all that multiplication? Something to think about. We'll find out the answer next time. See you then.